Alright, so in this video we're going to talk about solving systems of linear equations, and to be even more specific, we're going to be solving two variable systems, and I'm only going to focus on solving these systems by graphing. That way we can kind of visualize what a solution to a system looks like and what it is, okay? I'm going to talk about two different ways of solving systems algebraically, one of which will be substitution, another will be elimination, and each of those will have their own video. But today I just want to focus on graphing, alright? So we have our two equations here for the particular system. We have y equals negative 4x plus 4 and y equals negative x minus 2. And when we're graphing linear equations, you're probably most familiar with graphing using slope-intercept form. So that's exactly what we're going to do, and these two are already actually in slope-intercept form for us, okay? So all we have to do is we got to figure out what the slope and y-intercept of each line is. So if we look at this first line, I'll do this first line in blue. The slope of this particular line is negative 4, or you can even think about it as a negative 4 over 1. So we're going to be going down 4, right 1, down 4, right 1, or up 4, left 1, up 4, left 1 if we want to work backwards. And the y-intercept for this particular linear equation is going to be 0, comma, negative 4. So we can go ahead and plot that. So, and pardon me if the graphing's not that great. I haven't graphed on this in a very long time. So we have 0, 4 as our y-intercept, and our slope is negative 4. So we go down 4 over 1, down 4 over 1, down 4 over 1, and I can't get any more points over here, but we can go backwards. I'm going to go up 4, left 1, just so we can get kind of a nice picture. So that's not too bad. This will be our line for the first equation of the system, okay? So that is the equation of y equals negative 4x plus 4. Now we need to do our second line, okay? So the slope of this one is negative 1. You can also think about it as negative 1 over 1, okay? Negative down 1, right 1, down 1, right 1, down 1, right 1, etc., etc. And the y-intercept of this one, is 0, negative 2, right? 0, negative 2. So I can go ahead and plot this y-intercept, 0, negative 2. I'm going to use that slope. Down 1, right 1, down 1, right 1, down 1, right 1. And I'm just going to keep doing this until I run out of room or patience. And I'm going to go backwards as well so I can get a nice full graph, and I'm out of patience. Alright, so now I'm going to go ahead and I'm going to connect these. Ooh, or maybe not. And this is going to be a very rough sketch of our line, okay? So these are our system. This is our system graphed, okay? Now there's something interesting that happened. Right here. Right there, our lines intersected, okay? And that's actually where the solution of a system occurs. The solution of a system occurs where the graphs intersect one another, okay? I'm gonna try my best not to say lines, because we can have systems that aren't just linear, but in general, the solution to a system is where the graphs intersect. And in this particular case, the graphs intersect at the point 2, negative 4. So our solution to this particular system is the full point 2, negative 4. Don't write this as x equals 2, y equals negative 4. That's not entirely specific enough. The solution to a system is a point, so always make sure we write it as a point. So that's how we solve systems of linear equations, by graphing. We're simply just graphing every single equation in the system, okay? So that's an example where they're already given to us in slope-intercept form, but we can go ahead and do some that aren't given to us in slope-intercept form, something like this, okay? So in this particular equation, or this particular system, we have x is equal to negative 2y minus 6, and 2y is equal to x plus 2. I'm going to focus first on getting both of these in slope-intercept form, okay? And I'm going to focus on this one in red. So I have x is equal to negative 2y minus 6. And remember, when you're solving, when you're getting your equation in slope-intercept form, you are solving for y. Okay, we are solving for y. So I want to get y by itself. So I'm going to add 6 to each side. So I'm going to have x plus 6 is equal to negative 2y. And now I have negative 2 multiplying y. I got to get rid of that. We're solving for y. We're not solving for negative 2y. So I need to divide each side, the full side, by negative 2. So what this is going to become is we're going to have, and you can think about this as 1x, okay? We have 1x divided by negative 2. That is a negative 1/2 x. And we have 6 divided by negative 2, which is negative 3. So one of our equations is going to be y equals negative 1/2 x minus 3, okay? And I'm going to rewrite this with y on the left side because I know a lot of people get kind of confused by that. So we have it nice, okay? So there's one of our equations. And now we can pick it apart. The slope is negative 1/2, and the y-intercept is 0, negative 3. So we can go ahead and graph that. So 0, negative 3, down 1, right 2, 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 okay? And now I should work backwards as well. So up 1, left 2, up 1, left 2, up 1, left 2. Oop, skipped it. Whoops. Up 1, left 2, right here. Up 1, left 2. Up 1, left 2. So that's going to be one of our equations graphed. Okay, so I'm going to do my best to get this. Man, maybe I should get a ruler for this. All right, so there is one of my equations, okay? I'm going to go ahead and focus on this one now. I'm going to get this in slope-intercept form, and this one's going to be a little bit easier, okay? I'm solving for y. Well, y is almost completely isolated already. The only thing that's happening on this side of the equation is y is being multiplied by 2, so I can divide each side by 2. So 2 divided by 2 is 1, so I'm going to have 1y, that's what I want, is equal to each side, so everything, okay? So that's 1x divided by 2, so that's 1/2 x, plus 2 divided by 2 is 1, okay? So we have this in slope-intercept form. The slope of this one is a positive 1/2, and the y-intercept of this one is 0, 1, okay? So now we can go ahead and plot this one. Y-intercept is 0, 1, up 1, right 2, up 1, right 2, up 1, right 2, and so on and so on and so on. And then I want to go backwards as well. Down 1, left 2, down 1, left 2. And I'm actually going to stop right here because that is what we're looking for. Okay, that is what we're looking for. Man, look at that line. That's what we're looking for too. This is what we're looking for right here. This is what we're looking for right here. We're looking for that intersection point, okay? That's where the solution to a system occurs, okay? So for this particular one, for this particular system, the solution to the system occurs where the lines intersect, the graphs I should say intersect, and that occurs at -4, -1, okay? So that is our solution, all right? I want to cover one more because there are some special cases with systems, just like there's special cases with a lot of different equations, okay? So I want to take a look at this one right here, okay? I'm going to take a look at this one right here. Just like before, we need to get these in slope-intercept form first. And for this, for both of these, it's going to be fairly straightforward. All I got to do is I can subtract 2x from each side. So this first equation here is going to be y equals -2x minus 4, okay? So our slope is -2, or -2/1, and our y-intercept is 0, -4. So I'm going to plot that. So y-intercept 0, -4. Our slope is -2. So down 1/1, down 1, right 1, down 1, right 1. I'm going to actually go backwards too, just to be safe. Up 2, left 1, up to left 1, and so on, and so on, and so on. So here, here is one of our equations graphed. Okay, that's one of our equations graphed. Now I got to get the other equation in slope-intercept form. So once again, I subtract 2x from each side in this case as well. Okay, so I'm going to get y is equal to negative 2x minus 1. So in this case, the y-intercept is 0, negative 1. And the slope is also negative 2. Down to right 1, down to right 1, down to right 1, down to right 1. I'm going to go backwards as well. Up to left 1, up to left 1, up to left 1, up to left 1, up to left 1. I'm going to go ahead. I'm going to connect this. So there is our other graph, okay? Now in this particular case, we don't have an intersection point, and that's because these are parallel lines. What we have here are parallel lines. So what we're gonna have is a no solution in this particular case. So we have no solution, and that's because what we have here is a pair of parallel lines. We have the same slope but different y-intercepts. These graphs will never intersect. Okay, these graphs are never going to intersect. And remember, the solution to a system is where the graphs intersect. Well, if this graph never intersects, there is no solution. Okay, so that's one of our special cases. So if the graphs don't intersect, you don't have a solution. It's no solution. However, if the graphs are actually on top of one another, so let's just say for argument's sake, this equation here was y equals negative 2x minus 1. These graphs would lie on top of one another. It would be the exact same line. And in that case, you would actually have infinitely many solutions because it would be every single point that is on that line. So that's our two special cases. If you have a pair of parallel lines, they're never going to intersect. It's no solution. If you have two lines and they're actually the same line, they're on top of one another, you have infinitely many solutions, okay? So that's how we solve systems of linear equations in two variables by graphing. All right, in the next videos, we're going to talk about how to solve using substitution and elimination, all right? All right, stay tuned.